All right, so we're excited to look at this life cycle costing model that we were talking about. We built it initially in 2010 Excel, but it can run in all of those different versions. Now, this is the main menu screen. Um, Maximum run is limited to 10 times. The reason for that is you normally used to use it at three stages of the project life cycle. At the inception stages, when the project is just on a schematic design stage, you guesstimate the number of assets and the type of the assets, and from there you can build that. The second stage is post design stage, when you have a better picture of what assets are being populated into the model. And the third is the post construction stage, when the assets are physically installed and you know what those assets are. And so usually on these three stages, you can also update at any further, like 5 years down the facility life cycle for planning purposes. So you can use it for at least 10 times, and it depends on the need of each organization how they want to repeat those calculations year after year, or after every 5 years or 3 years. This is the main screen, as you can see. Let me see the annotation here. Let me pick up Spotlight. Okay, so this is all the main screen that we can see. In this side is the main menu that will take us to different sections of the model. For example, on the first tab is enter client info. So this basically is a combination of a client info and the password that people use to enter into the calculation mode. So for the sake of purposes, I just write here project 1 for the moment. Okay. If you give a, by the way, wrong name, then the system will exit and you won't be able to continue if you give a wrong name. As soon as we are here, then yeah, we can have those sorry, yeah, it was for a second. I'm just trying to get rid of this one. Okay, so this page is a client information page. Make sure they are done well, because this information has to be populated on all the reports that will be published later. So I don't know. I'm trying to get rid of this one. Okay, so project reference project. You can enter client information, all the basic information, right? So this information will be replicated in all the reports that the system will generate. So this is pretty much basic. The next is the set of global data. The global data means in here we set up the basic numbers for example, for electricity rate. What are the tariffs? We use different technicians or labors on each project. We have the rates that we define here. We have got some management costs. We have got their costs, and we define in here the durations of the different activities that we do. So whatever the durations in here, the system will pick one of them. In here, we define the system components. Let me take it here. Thank you. Let me pick one of them here. All right. So in here we have different components that we will define. These can be systems in a project. It can be areas in a project. It can be any way you like develop your work breakdown structure. All those systems will come. In case of, for example, in a mining or in an oil and gas, these systems can be based on the process. And in case of real estate or buildings project, they could be different systems serving the building. So for example, let's define a system here, air conditioning system. Let's define the next water supply system. Let's define the third system as a CCTV, and fourth as an go on like this one, you can define up to 20 systems in here. In here, we define the year-to-year inflation. And you would notice on year 14, I have bumped it to 50% just to see the some bumps on the curve, on the graphs, but we can change it to any year we want. Let's say make it 10%, let's say. In here, there are some more items we can reach to. There are some other costs. There are project insurances. There are overhead costs. And in case of facilities management operation, it's a help desk cost too, which is a percentage of the total project cost. Management costs, we want to define, or we have both options. We can define it as a percentage, we can define it as a number. Budget for reactive maintenance. So all these basic numbers that will drive the calculations are to be populated here. Trades, management costs, durations, basic electricity charges, the systems you define here, the yearly inflation, and the other miscellaneous costs on the project. Once we have defined that global data, that means that this is gonna be utilized in calculating operation and maintenance costs. Let's go to the next section, which is enter assets. This is the main screen of the project. In this one, the purpose for this is to populate the assets on the project and their frequencies, durations, all those numbers, and to come up with a calculation. As you see in here, there are 6 components, 4 or 5 components actually. Basically, there are 2 components: operation and maintenance cost and the capital replacement cost. And the operation and maintenance cost, as per the 3 components: labor cost, it has got material costs, it has got power consumption costs. You remember we entered the electricity tariff on the one of the previous pages, so this is gonna be used in calculating the power cost and specialized costs, like we give a subcontract, and then we've got the capital replacement costs. On this side is basically basic worksheet tools like validate data, save projects, save and exit, check blank, format sheet, zoom control. That's a little thing that we can use in here to control, focus on specific areas of the sheet, or we can like increase the width or whatever. So it's a good handy tool for when you're deep diving into the data. This is the link to the other pages, main page, global data that we entered, and this is a link to the master database. And in here is the export data. So we can export all this information as another sheet and save it as a separate file. Now let's go to the labor cost here. So the labor cost or material costs. So let's go first to the labor cost. Let me get rid of this one here. Okay. On the labor costs, first of all, we pick up the systems in here. You remember we defined some systems before, and we are picking them one by one. Air conditioning system. The second system we are picking is a water supply. The third, let's say we pick up CCTV. And the fourth system we pick up, let's say, electrical. So we can define all those systems and they will be available with each asset. Now in here, we are going to pick up the assets in the project. So for example, air-cooled chillers is the first asset that we will pick up. We can replicate the same air conditioning system as long as all the assets are populated in here. But for the sake of simplicity, I'm taking one system, one asset. We can have more assets in one system too. Now the second, for example, asset we take in here as the fan coil units, and the third asset, let's take extract fans or fresh air handling unit, and let's take the fan coil units in here. So as you can see that we just have to pick this one. This whole data, this whole sheet is linked to a standard maintenance regime sheet, in which we know that an air-cooled chiller has to be cycles per year 4 times. It has to be maintained. The interval is 3 hours. Sorry, the interval is 3 hours every 3 months, and 4 months actually, and one transaction time or duration is about 6 hours. We need four people, laborers. We need one supervisor, one manager, and here we can pick up those people as well. So this is all to calculate just the maintenance cost. So as you can see that, notice this whole line, please. And if we are going to pick something else, all those numbers are going to be changed. So these numbers are picked from the master database where we have already defined the standard maintenance practices. So this is the labor cost we entered. Let's go to the material cost. In here we are mentioning our assumptions that we assume that it will be maintained 6 times a year or whatever. And then we know this cost comes from the maintenance regime database. And then we have this cost source as well, for example, taken from XYZ supplier for this material, right? Now, in here we have got, actually in each one of those costs, I provided an alternate cost per year. Sometimes we don't, we just give a subcontract to maintain, for example, in this case, these air cooled chillers, and the company is responsible to do all this planning. All we do is just enter a number here given by the company that, okay, this is $7,000 a year, or dirhams a year, whatever. So this is also possible. So this is the material cost. Then we go to the power consumption cost. We enter, we know there are 12 chillers like this, and equipment connected power, rated power is 30 kilowatt. Units in operation are 12. Then we have got this some connected power, utilization factor, total power consumption, and obviously this power consumption is going to be multiplied with the electricity tariff to come up with the running operation costs of the electricity, which is the bill that we will be paying. And so each one of the, again, this is linked with the database as well. Now in here, we go for specialized costs, and there are some specialized costs as well. Let me do a little zoom control. Thank you. All right. So in here we have got the specialized cost contacts. For example, the elevators, the escalators, the BMS system, or the instrumentation and control. They usually come under a specialized contractor's cost. And we mentioned here the specialized contractor cost per transaction, and then it is multiplied by on yearly basis. We can like, I'll show you some little details on the. All right. Once we have entered all those components in here, before we run into calculations, let's see some of the features here. We know that sometimes if I see that the number is the overall operation and maintenance cost is very high, and I want to tweak those frequencies from 4 to, let's say, I just want to make it 2, right? And make it 6 monthly. So what happens is, in this case, I will get a obviously lesser maintenance cost. But how much am I deviating from the maintenance regime? This is the question. So similarly in here, for example, we can change this duration in here from 4 to 1 hours. So if we do these tricks in this sheet, it's thousands of entry, and we don't know which one cell has been changed and which one not. To validate, we do use this validation data tool. So when we do validation data tool, it will manually enter data will be marked in yellow background. So all the numbers that we mentioned in yellow background, they are deviating from the standard maintenance regime, and therefore we know that we change these numbers. Again, there is a button that we can press here to get the default values again. So as soon as we press them, it will go back and replace those numbers with the default values against each of those assets based on the standard maintenance regime. Similarly, we can use these ones as well. We can have the good thing is that the arrows work with this one. Yeah, we can run this on this here as well. All right. So, so all of those anywhere we have an always option to go for the default values where we can pick up the default numbers, although we can change any of those numbers too. Um, so these are a few things. Sometimes we copy and paste on the sheets, and we can see that the format is not consistent. We can use the format sheet button to which will reformat the entire sheet. Once again, fix the cell weight, everything. It check blanks. It tells you the blank cells in here. Um, it's zoom control we have already seen. Data validation, some cells are restricted, but we need some access to them, and we can use the remove data validation tab to do that. On this side, link to the other pages, added global data that we were looking at the second screen, master database and export data. So once we have populated all this one, we would like to actually save that data. So we press the export data, and first thing it's going to save is the asset register. So let's press the asset register, and let's go to this area and save the asset register. Yeah, continue. Thank you very much. And we can use the OPEX, operation and OPEX entries. So operation and maintenance cost. Again, so let's go back and see our folder in here. You will see that the asset register has been nicely columned and nicely properly stacked in here. We can use that one. Similarly, the operation and maintenance entries that we did, power consumption, cost per year, all of those costs are coming in here. Let's go back to the same screen. Bear with me for a second, please. That's quite a complex. Let's close this one. Let's close this one too. All right, so we are back on our main page. Let's go back to the auto open section once again. All right, now once we have entered all of those assets in here, as you can see, it's a time to run the calculation. So let me take the opportunity to put this in here. Okay, now we're going to run the calculations. So all it is doing is based on 2 or 3 different sheets input, it's going to run the calculations. Okay, so you can run it as I said earlier in the discussion 10 times, but you can customize it whatever you like to. So it is running all those calculations behind. There are, just to introduce you, in total there are about 2,500 routines and subroutines running in the background. So this is our result sheet. We have got air conditioning. Pull this one here. This is coming all the time out of the way. And the way actually. So okay. So OPEX and CAPEX computation. It has got system by system. It has got complete system cost sheet. It has got executive summary. So let's go to the executive summary first. As you can see in here, it has all those system components in here. It has got the operation and maintenance costs in here. It has got the capital replacement costs in here. It has got the total cost and the percentage of the total cost. This column now is very important because we can benchmark from here that similar projects, the air conditioning, for example, for another project was, let's say 20% of the total project. Are we under investing on this component, or the supplies are cheaper, or electricity is cheaper? That's what we need to figure out actually. And this can be a very good way to benchmark similar projects, especially in a portfolio structure where you are running multiple projects. In here are some other smaller costs, overhead costs, insurance costs, management, help desk, budget for reactive repairs that we defined in the main input sheet. So this gives us a year one executive summary. This is the obviously the total cost, and this is it gives us a number 4 million 430,000 whatever. So we can run this one for every year. So let's say go for year let's say 8, and we press it, and it is refreshing that information, and we'll see that how much it jumps. So this is where actually the inflation is kicked into these year by year, and it gives us about 2.9 million and 3.1 million, and total about 6 million. So this is a brief summary, system by system, O&M cost, capital replacement total, and percentage of the total. But we can drill down to system level summary as well. So let's go to the summary menu. In here, we have got all those components. The way we saw the system summary, let's look at the air conditioning side. On here, we have got the operation and maintenance costs, which are it has got all those components. We know that 12 numbers are in operation. This material cost, power, specialist contractor, and total cost. So this is 1 year cost. We can go for 5 year costs, and we know that year one has got these costs, O&M capital, O&M capital, O&M capital. So this is for 5 years. We can go for all the costs as well. So for this component, and we know what is year by year costing. The analysis of this data also tells us if there is any major problem somewhere. So for example, if you remember or not, in the start we had got um, uh, so yeah, so year 13 is this one, um, 14. So all of those costs are up to 15 years this year. Go to the again, we have got option of zoom control if you like here, all components, summary page. So we can pick up any one of those components. I will run through quickly now here because we still have to go to graph and printing options. So it's updating the summary. Let's go to the graph menu now. So in here we have got the operation and maintenance graph. So this graph is going to operation and maintenance cost for each of the system in terms of, and that's the yearly cost. And this is the percentage of those costs. This is the total, and these are the components cost. Similarly, we have got annual similar graph for the annual capital replacement cost, where all those systems are here. Their cost is here on this axis. This is the total cost. Again, as you see, you can run calculation for any one of those years. OPEX and CAPEX component here. So in here is the OPEX and CAPEX total cost for each of the system, total cost here, system, and here is the cost in millions. Again, as we said, we can discuss it for every year. In here, 15 years estimated project expenses. Now this is the entire project expenses nature. So we're gonna press this one, and it has this graph that's gonna be probably update here. That gives us a operation and maintenance and capital replacement and total cost, 3 lines. You can see that one of them is operation and maintenance, one of them is the capital, and the other one is the total cost. Here is the region, probably not very visible. We need to make it more visible. So it's still updating that, if you can see here. So on this axis are the years, and this axis is the total cost in millions. I'm using an i7 processor. It takes about 40 seconds to 1 minute to update this graph. I'm not sure on the i5 or i3 processor. Well, mine is 4th generation actually, so maybe an i5 with a better generation could respond better. Especially, I think I would suggest to minimize all other applications to make sure you get the calculations the right. As you can see in here, while we go through, there's a printer button. So when we print this one, this graph will be printed in a PDF or any other one. Okay, so it has been refreshed now. Let's try one of those printing options. So as we press the print button, it will send a print to the default, which in case my case is a PDF printer. So let's save it as LCCM and save it. All right, so here is the PDF version of that. You don't have to select anything. It just gives you a printout of what you are expecting. The graph is updated. Okay. Okay. Going back, main menu. So in here is the core FM cost and the contingency cost. So this graph tells us like what are the different costs and contingency costs. So operation maintenance is here, capital replacement is here, contingencies are here. Again, you can send a print here. Core FM costs and contingency costs. Contingency cost component. This graph gives us within the contingency costs like management costs, insurance, budget for reactive repair, help desk, and overhead costs. It gives us the components of them. Again, you can send a print here. Now we can go down to 15 years expenses curve for each of the systems. So let's take this CCTV component and see what it does. So on this scale again, it is years, and these are the years from year 1 to year 15, and on this scale is the accumulative cost year by year. So as you can see in total overall, if we populate for 20 systems, there could be around over 100 different perspectives to see the costs and or see those 10 charts. But the beauty of this software is that, which does not make it very heavy to operate, is that all those 100 graphs are going to be updated on the same one graph. So every time what it does is it calculates the things, bring into a buffer sheet, pastes over there, and from there plots these new points on the curve every time. So that means that it doesn't have those 100 graphs. That doesn't make it very heavy, as I said. It's just the same one chart that is being updated all the time. So I think there are still 1, 2, 3, 4, quite a few points. So it's still doing the calculations. It is updating those points as it receives the process data from the softwares and routines they are calculating. As you can see, once the graph is complete, you might notice that even the axis scale would be changed here. All right, so this was for the CCTV. We have got the operation cost, maintenance cost, operation maintenance, capital replacement cost, and then we have this is our total cost here after years. Again, we can send a print here. Similarly, any of those systems you can pick up and you can, for example, have a let's see this water supply system. As it does, as I said, it updates the same graph all the time. Every time a new, it runs new routines of calculations and delivers the data to plot this graph. Just a little running behind with the schedule, but hopefully we'll finish it. This model is very helpful, especially on a projects where you are building and operating and maintaining those projects, like the one with the PPP projects. You have to keep an eye on cost-efficient design, which is maintainable and is optimized for operation use. So we can run this model, as I said earlier, at a design stage, and then we can come back to the design team and tweak those design for a cost-efficient operation for the facility lifecycle. And this is a very helpful tool to deploy at the design stages. And similarly, at the post-construction stages, we can have a validation on what our costs, and further down the line, 10 years, we can see are we matching those costs or not. So this was the other system. Let's go back. Executive summary, we have seen that. Let's go to the main page here. We have got this page, graph page, we have just visited, and now we are going to the print menu. On the print menu, you have tons of prints, actually, tons of prints you want. Executive summary, you want of first 5 years, next 5 years, or the last 5 years, or all 15 years, or you're gonna need any one of those years. Then you've got the assumptions page that you can print off here. So this is a high level kind of view. On the operation and maintenance side, you have got, again, the same structure as the executive summary, first 5 years, following 5 years, or the last 5 years, or the entire 15 years. You can select any 1 year here as well. After the operation and maintenance, the next is the capital, which is a similar approach. You can select any years, and the same approach is the total cost. And then we have got the 15 years trend line charts, all of them for different components, cost line charts, 15 years select component cost charts. So you can select any one of those components and get a straight away print. Obviously, the contingencies are the next in line. Share various contingency components in total cost. So all of those components, you just press these buttons and it's gonna send you a print. So for example, if you print this one, what I expect is a 15 sheets A3 size in the printer with all those executive summaries of each system for 15 years. Any one of them would give us 1 year. So that's a little walkthrough for this model that we prepared. We hope to you enjoyed this session, and if you have any further questions, please do not hesitate to contact or reach me, and we will be more than happy to answer your questions. This software can be customized to your needs, project needs. It can be customized to your organizations with right logos, right frames in it. It can be customized to your it can be customized to your clients. So it's a very helpful model in terms of keeping an eye on the operation costs at a concept stages, at a design stages, construction, and 5 or 10 years down when once you have completed your construction to match with your original budgets. So thank you very much for joining me in, and have a wonderful day.